Today I want to talk to you about vaccines, about the worldwide race that's going on right now to find a vaccine against COVID-19. All right. According to the World Health Organization, there are more than 100 groups trying to do this right now, but only 10 of them are at the point where they can test it on humans. Okay. The other thing is, under normal circumstances, it usually takes about 10 to 25 years or longer to create a vaccine and get it approved, believe it or not. The other thing is, vaccine trials, new vaccine trials, typically have a 90% failure rate. So we're up against some steep odds here. Okay, the one good thing is that all vaccines are based on one relatively simple idea. And let me explain. When you are infected by a virus, your immune system mobilizes, okay, and then goes to the scene of the attack, sizes up the virus, and then on the spot designs a custom-made antibody to basically put the virus into a hammerlock and then destroy it. All right, so think of antibodies as custom-made straitjackets, okay? I explained all of this in the last episode, but what I didn't tell you is this. When the immune system sizes up the virus, it doesn't look at the whole virus. It looks for something unique about the virus, something telltale. Usually it's a protein on the surface of the virus. It's what we call an antigen, okay? So when the immune system sees that antigen, sees that protein on the surface, boom, it attacks the entire virus, okay? So think of it as a bad guy in a movie, wearing a black hat. You don't have to see the whole villain. You see that black hat, boy, that's the bad guy. Okay, so the key idea with vaccines then is to flood your body with black hats. Not the virus, but just the black hats, tricking your immune system into thinking that it's a virus and then creating all these antibodies against the virus, okay? In Texas, there's an expression, all hat and no cattle. Well, that's kind of what we're talking about here, okay? So the key here is to do that, to flood your body with these black hats in a way that is safe, cheap, and scalable in case you have to make vaccines for the entire world, all right? So in our case, in the current pandemic, the villain is the coronavirus, and the black hat are those spikes on the surface of the virus, okay? The club-shaped proteins, those are the antigens. And that is what your immune system keys into. When it sees that, it knows it has a virus, okay? So the key is to trick it into thinking that there's a virus just by flooding your body with these club-shaped proteins, all right? There are a number of ways of doing that. Let me tell you about three of the big ways, okay? Number one is what we call viral vaccines, okay? This is where you're injected with a common virus, like a virus for the cold or virus for the measles. But the virus has been crippled, okay, so that it doesn't cause the disease. And number two, it's been genetically reprogrammed so that when it gets into your cells, it takes over the machinery of your cells to produce lots of club-shaped proteins, okay? Again, then tricking your immune system into creating these antibodies. And then these antibodies are good to go when and if you're ever truly infected. Your immune system has now been educated and can create these antibodies quickly, all right? That's the whole idea behind that. Now, this particular strategy is being used by Oxford University in collaboration with a company in England called AstraZeneca, all right? They have tested their viral vaccine using a kind of a rhesus monkey virus, okay, that again, that has been deactivated, so it won't cause the disease, and it's been reprogrammed. They've tried it out on rhesus monkeys. It seems to work. And now they're trying it out on about 1,000 people. All right. Now, the United States, the Trump administration has bet $1 billion on this viral vaccine in exchange for a promise to get the first 300 million doses by this fall. So we'll see if that was a good bet or not. The second big strategy is what we call DNA or RNA vaccines. Okay, in this case, you are injected with little bits of DNA or RNA which have the recipe for making club-shaped proteins. Okay, so when those get injected into your system, those little bits of RNA or DNA go into your cell and take over the machinery of your cells and create millions and millions and millions of these club-shaped proteins. Okay, so this is a strategy that is being used by a company in Massachusetts called Moderna. Now, they've already tried it out on 45 people. It's not a lot, but they've tried it out on 45 people with some promising results. 4 people had bad reactions, not serious, but they had bad reactions. One of them had a fever, got really nauseous, even fainted. He's okay now. The problem with these kinds of vaccines, the DNA RNA vaccines, is they've never been tried out on any kind of disease. So these are literally shots in the dark. We'll need to see how it works out. The third kind of strategy for making vaccines is what we call antigen vaccines. And in this case, what you do is you inject somebody with the club-shaped proteins directly. You don't need the recipe, you don't need another virus to carry it in. You just inject them directly with the antigens, with the black hats, with the club-shaped proteins, okay? So this is a strategy that is being followed by a company in Paris called Sanofi. They plan to go into human trials later this year, and they are planning to have a vaccine, hopefully if all goes well, by the end of next year. But this is a traditional technique, okay? But the problem here is that unlike the other strategies, when you're here where you're just directly injecting the club-shaped proteins, the black hats, the antigens, they'll die out after a while. So you need booster shots, okay? It's not a big deal, but it's a little bit of a downside. All right, let me leave you with 3 final thoughts. Number 1, we're going to need a whole lot more studying, a lot more testing with humans before we can sort out which are the winners and which are the losers, okay? And remember, we're facing probably a 90% failure rate. So again, it's an uphill struggle. The second thought is this. Right now, when we're testing these new vaccines on a person, we're just checking to see whether their immune system reacts and starts creating antibodies, these custom-made straitjackets for the virus, right? Sooner or later, sooner preferably, we're going to need to see how well these new vaccines work against the real deal. All right? So it almost certainly means that we're going to have to deliberately infect people with the coronavirus to see if these vaccines are going to offer them the protection we hope they do. And so we can only hope that enough people in the world will be willing to volunteer to be deliberately infected with the coronavirus. Would you do that? I don't know. If I were much younger, I might, okay, in the name of humanity, in the name of science. All right. The third final thought is this. A recent poll was taken of Americans, and only about half said that they would be willing to take the vaccine if and when it comes down the pipeline. So creating the vaccine is only part of the challenge. Then we're going to have to convince people to take it. Now, can the government force people to take the vaccines? Should they? Is that a good idea? What do you think? Anyway, that's it. Something to think about. All right, as always, thank you for watching. Until next time, stay safe, stay strong, and no matter what, my friend, stay positive.